Welcome back, everybody, to another TLC conversation on various different experimentation topics. Today, we're talking with Lizzie Eardley. It's been a while since you've been back. Really glad to have you. And she's going to talk to us about, with great power comes great responsibility. And our power here is experimentation, and our great responsibility is to do a better job understanding our stats. So let me introduce Lizzie, who, any of you who are not aware, she's really unique. I got to hear her speak at CXL a while back, and one of my favorite things about her, she gets up on stage, she says, well, I'm an astrophysicist, and I'm like, wow. So she's like literally a rocket scientist. So, came into the world of digital experimentation through interesting channels, which I'll let her share with you. But she's on a mission to make statistics less scary, which I think all of us can appreciate. And both this talk today and then several weeks from now, 3 weeks from now, Lizzie will come back and join a panel conversation led by Tim Wilson, who will be talking about the importance of statistical intuition. So don't miss those two conversations. And then we'll have another conversation with Dr. Ellie Feit, also on statistics, because, well, frankly, statistics matters. So Lizzie, I'm going to stop share and let you take over share. And as I'm doing that, I'll remind everybody to mute your lines to avoid as much background sound as possible. Use the TLC Slack to submit some questions or take yourself off mute and ask those questions. And we will get started. Looks great, Lizzie. I can see your screen.
Great. Let's see. 1 second. Cool. Great. So hi, everyone. And thanks, Kelly, for that great introduction, making me sound like a rocket scientist is always good. I'm Lizzie. I'm a data scientist. I'm currently working at Split. And Split's a feature flagging and experimentation platform. So I'm mostly focusing on the experimentation side. So I spend my time trying to make sure that we present the most kind of accurate and insightful experimentation results, but also trying to promote some best practices. So you'll hear some of that in this talk. While I'm talking about Split, I'll do a quick plug for our conference that's coming up. It's free, and there's a great agenda, including some familiar faces like Lucas, who's on the call. So if you're interested, check that out. So before I joined Split, I was working at Skyscanner on their internal experimentation platform, and before that at Booking. And as Kelly said, before that I was working in astrophysics. It's actually pretty similar really to data science. It's still using stats and data, but instead of trying to use it to make decisions, using it to understand different parts of the universe. But this talk is all about experimentation. So the subtitle is, with great power comes great responsibility. So I'm going to split it into two parts. So the first part is focusing on the power of experimentation. So what is it that makes experimentation such a valuable technique? And the second part is going to talk about the responsibility of experimentation. And by responsibility, I mean those kind of best practices and the guidelines that you need to follow to make sure that you're maintaining the high level of accuracy and rigor that experimentation can provide. So I'm going to explain 4 things that make experimentation really powerful, but then 4 things that you need to keep in mind just to make sure that you are harnessing all of that power and to make sure that you're getting the most value out of your experiments as you can. Cool, but first, taking a step back, why do we need experimentation in the first place? Where has this need arisen from? If we think about how engineering has evolved over the last few decades, we've moved from like yearly updates, yearly changes to things to now releasing and updating every single day, or even hundreds of times a day. So engineering teams are just moving way faster than ever before. Frequency of updates has just absolutely skyrocketed. But then this naturally begs the question of all of this extra speed, are we actually delivering more value to our customers, or are we just shipping shittier software faster? So experimentation gives us a way to answer this question. So it gives us a way to kind of change the way that we work and the way that we define success. So instead of focusing on speed, so things like how many features you deliver each quarter, we can start to focus on the actual value of those features, how they're really impacting the end users and the business. So experimentation gives us a way to, instead of focusing on output, start focusing on outcome. And so this is super important. And that's because there's this hard truth that it's actually really not that common to get it right. So our expectations and our predictions of how people respond to what we're doing, they are often wrong. So Bing did this famous study where they measured how many of their features actually had the intended positive outcome. And they found that only 10 to 20% of them did. So this means that 80 to 90% of the time, like 8 or 9 features out of 10, they're not necessarily providing any value at all to the end users. So it's really important to normalize this reality. So normalize the fact that it's common to get it wrong, and that's okay. And also the fact that just because you don't reach that intended positive impact, it's not necessarily a failure, right? So as long as you've learned something in the process, as long as you've run a well-designed experiment, that's still a success. So I'm sure you'll agree that it's better to know how people actually feel about the changes that you're making and the things that you're working on, rather than just continue to like blindly invest your resources in things that aren't having the impact that you hoped for. Cool, and then I'll take one more step back and just clarify exactly what I mean by online experimentation. So technically, I mean controlled experimentation or randomized controlled trials. And this is just an experiment where everything is the same except for one particular thing that you're controlling, so one variable. And that one thing, it might be something like the copy in an article, it might be an entire redesign of your website, or it might be some invisible backend change. But the main thing is that everything is the same, everyone's experiencing the same thing, except for that one variable that you're controlling. So I wanted to clarify the difference between online experimentation and controlled experimentation, because this technique has actually been around like way before anything was online, before online was even a word, right? I like this fun fact because I used to live in Edinburgh until a few months ago. So apparently the first documented controlled experiment was run by a doctor from Edinburgh. And this was way back in the 1700s, hundreds of years ago. And the story here goes that at a time when many sailors were dying from scurvy, this doctor, he noticed that fewer sailors were dying on Mediterranean ships. And this observation led him to hypothesize. So the reason that fewer sailors were dying was because of the citrus diet. And he tested this by running a controlled experiment. So this was designed by choosing one particular voyage and giving half of the sailors on that voyage limes. But other than that, everyone just ate their normal diet. So the only difference there was the limes. That's that one variable he was testing. And of course, this was a great success. So it ended up leading to limes being added to the rations. I'm told it's where the British get the name limeys from. So, and it also, of course, just saved a lot of lives. So experimentation can save lives, and it still does, but now we can also put it to use in many, many more ways. So because we have all this data now, because everything's online, we have this ability to test and to measure the impact of even the tiniest of changes. And this is an example of one of those 10 to 20% of things experiments which did have a positive impact. And I think it's a great example because it's really surprising. So it's one of those things that you'd never have guessed would have such an impact, and you'd have a really hard time convincing your colleagues that it was going to have such a big impact. So here, what they did was they slightly changed the colors of their text and of their captions from the colors on the left, the control colors, to the colors on the right. So it's even the same color, just a slightly different shade, right? But this tiny change increased their revenue by $10 million annually. So a huge impact. And this is why experimentation is so powerful, because you're able to test all of these tiny ideas and then find those unexpected gems that have this huge impact. And this is why it's such a prevalent technique, right? So it's all around us. So your big tech companies, they're all running tens of thousands of experiments every year. If you're a social media user, then you're probably always going to be in a whole bunch of experiments without realizing, because yeah, everyone's using experimentation. But the great thing about it is that you don't need to be one of those huge tech giants to use experimentation, because the way it works at a high level, it's actually just pretty simple. So when people come to your site, your product, or your app, you just randomly assign them into a group. And that could be as simple as like a random number generator. If someone comes, you give them a random number. If their random number is less than 0.5, they're in group A. If it's greater, they're in group B. And then so depending on which group they're in, they'll see a slightly different experience. And remember that slight difference in the experience is just that one thing that you're controlling. So you do this for a while, you let it run, and then you collect the data and you decide which version works better. And of course, it's not quite as simple as that. The last part of just deciding which version works better, there are definitely some nuances, and we'll get to that in the second part. But fundamentally, experimentation is simple and anyone can start doing it and getting value out of it. Okay, but even though it's simple, it still does take some time and some effort. So why should you bother? So I often get asked, why do I need to go to all the effort of doing a proper controlled experiment rather than just using analytics? Is it okay to just kind of measure what my metrics look like last week and compare it to next week? Well, no, not really. There are plenty of reasons why experimentation is so much more powerful and adds so much extra value. And these four, I think, are some of the most convincing arguments why experimentation is really worth investing the time in. So I'll go through them one by one. So firstly, experimentation lets us remove the influence of external factors from the data. So there's always a whole bunch of things changing in the world all the time. So that could be things like current events, news stories, new COVID restrictions, or something as simple as the weather, right? So on a hot day, people are more likely to go outside and not spend time on their laptops. So this is why it's really not a good idea to release a new feature or make a change and then compare like last week's data to next week's data. Because when you see a difference, you're not able to know whether that difference is due to the thing that you changed or whether it's due to all the other things changing in the world all the time. But experimentation gives us a way to remove those influences. So because we're testing everything at the same time in parallel, we can know that when we see a difference in the metrics, it really is due to that one thing that we changed, that one variable we're controlling. That is, unless it's due to noise. So that brings us to the second thing that makes experimentation really powerful. And that's that it lets us distinguish between random noise and a real meaningful signal. So there's always going to be this kind of randomness, this random variations, and this noise in data. So the way people behave today is going to be slightly different to the way people behave tomorrow, just because of random chance. And you can think about this by imagining flipping a fair coin 100 times. So you're actually pretty unlikely to get exactly 50 heads and 50 tails, no matter how fair that coin is, and no matter how perfect you're flipping it. So it's actually only 8% chance. So my point is that just because you see some difference in the data, so maybe you see 48 heads and 52 tails, that doesn't mean the coin is biased. That doesn't mean you've measured a real meaningful difference there, because it could just be due to random chance. So experimentation kind of gives us a framework to say whether the difference that we've measured is meaningful or whether it could just be explained by that random noise. And it does that by measuring more than just the metric value itself. So it also measures the variance in the metric and estimates the distribution of the metric. And then we use statistics to kind of draw a line in the sand to decide whether we can say it cannot be explained by noise and it really is meaningful and we should go and interpret it, or whether we can't really say anything and it could just be due to kind of the expected variations. Cool. So this is where statistical significance comes in. So it's a term you hear all the time in experimentation, and it's just that kind of stamp of confidence that the difference you've measured cannot be explained by noise, and it really is something that you should trust and you should look into, and it means that you've had an impact. So it's often the difference between like celebrating a successful feature and kind of going back to the drawing board and reiterating. Cool. And then another thing that makes experimentation really valuable is that it removes human biases from the decision-making process. So there's a huge number of cognitive biases that influence how we all think, how we process data, and how we make decisions. There's a tendency to see patterns in data when it's not there, or there's this recency bias where people kind of remember and focus on pieces of information that they've learned recently. We also have this human tendency to overweight evidence that agrees with either what we already believe or what we hope to be true. So by running scientific and tightly controlled experiments, we're able to make better decisions because we can remove these biases and make sure that we're truly following the data. So in a way, it's kind of counterintuitive because by being really scientific and by removing our emotions from the equation, we can actually hear the voice of the users more clearly, right? So we're not going to be influenced by our own desires to be right. Okay, and then the fourth thing that I want to mention that makes experimentation really valuable is that it can really improve the way that we release features and we make changes. So if we get in the habit of releasing all of our features, all of our changes behind an experiment, then it gives us a way to rapidly detect when things go wrong, but also to pinpoint where those things are going wrong. And that's because with experimentation, we can start to measure things on a feature by feature basis. So it gives us a way to like drill down into just the relevant segments of users and then see data for only the people who actually saw that thing we changed, and then compare it to a statistically identical set of people who saw the original version or who didn't see that thing. So it gives us a much more precise and informative view. So this image here is trying to kind of compare the difference between having experimentation when you release your features and not having it. So it's depicting one particular scenario, but seen through two different setups. So the setup on the right is when you release things behind an experiment. And the setup on the left is when you just look at things globally, right? So you're not looking on a feature by feature basis, and maybe you're just using analytics or like a standard ABM tool.
I didn't lock it.
Okay, so the example scenario here is that you're releasing 3 features and you're releasing them kind of cautiously. So only 5% of your users see each of those originally. And it just so happens that one of them has a bug. So that's feature 2 in this example. And here, 40% of users who see feature 2 run into some exception or some error. So maybe everyone who comes on a particular browser, like Chrome, sees a bug that wasn't caught in testing. Well, If you were just looking globally, so you just look at all of the users and see how many people see an error, then all you would see is that 2% saw that error, because that's that 40% of 5%. So that's pretty hard to interpret that, right? So you're not going to know, is that really meaningful? Is that really something you need to prioritize and go and look into straight away? And when you do look into it, you don't really know where to start looking. But if you're releasing everything behind an experiment, then you're able to see immediately 40% of people that saw feature 2 saw an error. You know which feature is causing it. You can then go and roll it back straight away and go and debug it. So releasing things behind an experiment really kind of reduces that time to resolution, and it gives you a lot more safety and confidence in your deployment cycles. Cool, so there were the 4 pillars of power, if you like. So 4 things that make experimentation a super valuable technique. But now we're on to the responsibility part, because with all that power comes some responsibilities. So experimentation can give us this amazing statistical rigor and scientific accuracy, and it can give us some really strong and quantitative claims on things like how confident we can be, or what's the range of potential impacts, what's our chance of drawing an incorrect conclusion here. But there are some certain best practices and kind of guidelines that you need to follow and keep in mind, just to make sure that you are maintaining that level of rigor and accuracy. And also just to make sure that you're getting the most value and the most insights out of your experiments. So I picked these 4 best practices to talk about, but there are plenty more, but I think these are 4 pretty big ones. So if you're doing these, then you're probably running a really great, trustworthy experimentation program. Cool. So I'll go through them one by one again. So the first one, it's really important to start with a hypothesis and then also stick to that hypothesis when you're doing the analysis. So here's an example template of a potential hypothesis, but basically it's like a prediction or a statement or something that your experimentation aims to support or refute. So ideally a hypothesis needs to be clear, needs to be concise, and it needs to be testable. So by testable, I mean that the data that you're going to collect in your experiment needs to be able to support or refute that. Hopefully it will include some kind of decision criteria or a way to define whether your experiment is a success or not. And usually that means that there'll be one key metric which is pulled out in the hypothesis. So this makes it really easy to kind of decide on the next steps, because you've already decided exactly what it is that you're looking at. So it's really important to define a hypothesis up front. So that's before you've seen any of the data coming in. And that's because it removes those human biases that we talked about. So as soon as you start letting the data kind of influence your decision criteria and your analysis, then you're losing that kind of scientific rigor and accuracy that experimentation can provide. And this saying kind of encapsulates that. So if you torture the data long enough, it will confess to anything. So this means that if you go looking for a signal, so if you go slicing and dicing the data and go trying to find some data which supports your expectations or what you're looking for, then eventually, yeah, you will find something. But as soon as you stray away from that original hypothesis, then you're losing the accuracy of experimentation. And it's not going to be as reliable a conclusion. So this here is an XKCD comic, which I think is a good example of this. So it's kind of an example of an irresponsible experimenter. So here in this example, these XKCD scientists, they're testing the hypothesis that jelly beans cause acne. And the original data that they gather, it doesn't support that. So they don't really find any meaningful signal there. But they're not happy with that. So they go and they slice and dice the data into different colors of jelly beans. So when they don't find a signal overall, they start looking at purple jelly beans or brown jelly beans. And in the end, they test 20 different colors of jelly beans. And eventually they do find one which looks like it causes acne. But at this point, they then tested 20 different hypotheses, and they've sliced and diced and they've tortured that data until they've found something. And it's confessed to green jelly beans causing acne. But because they've strayed from that original hypothesis, they're losing that rigor. So they can't really be confident in that conclusion about green jelly beans. So the best practice here, what a responsible experimenter would do, is to rerun the experiment, but this time the hypothesis explicitly targeting green jelly beans. Okay, so then another thing to keep in mind when you're designing an experiment is to make sure you've invested time to choose the right metrics, because having the right metrics can really kind of totally change how much value and how much insight you get from your experiment. So there's no ideal metric all the time. There's no kind of right and wrong, because it really depends on your business model and what it is that you're trying to measure. But there are some common characteristics of a good metric. So firstly, a good metric is meaningful, and that means that it's really directly capturing some business value or some customer satisfaction. So for example, maybe looking at how many people read an item description is really interesting and it's a very insightful thing to capture, but it's probably not going to be a good key metric because it's not directly capturing meaningful business value. So maybe instead you would want to measure how many people actually purchase an item. That's really directly capturing the signal of whether the customer actually wanted the thing they saw. So a second characteristic of a good metric is that it's sensitive. And this is actually a particularly hard one because it's not always possible to increase sensitivity or to make sure that you're measuring a sensitive metric. And by sensitive, I mean that the metric should kind of move and respond to small changes in behavior. So it's difficult because some really meaningful metrics like lifetime value or retention or churn rate, they're not inherently sensitive because they're slow moving and they're kind of low signal. So if you can, the ideal key metric would be sensitive. Okay, and thirdly, a good metric is directional. So this means that when it moves up or down, you immediately know whether that's a good or a bad thing. So for an example of a non-directional metric, you could think of, say, purchases per session. So let's say that goes down. Maybe at first you think that's a bad thing, but it could be that purchases has gone up, but then sessions has gone up even more. So maybe you've just released some great content, you've given people a reason to come back again, more and more, and that metric has gone down. So this is why it's not a great key metric because you're not able to decide what the next step should be based on that alone. You need to have more information. So you should really always intend to have a directional metric as your key metric. Okay, and then finally, a good metric is understandable. So at the end of the day, you've got to convey the experimentation results to your stakeholders and to your business executives. So anyone in the business should be able to quickly and easily understand exactly what that metric represents. Cool. Okay, and then here's another example of an irresponsible experimenter. So this here is an image that a Chinese shoe company used for an Instagram ad. So it's got a picture of a fake hair on it. So their thinking was that when people are browsing through their phones on Instagram, they see this and they think they've got a real hair on their phone. So then people go and they try and swipe away the hair and unintentionally click through on the ad. So here, this is an example of gaming the system, right? So it's someone trying to get a positive, significant experiment, trying to get a success there, rather than aiming for something meaningful, rather than really trying to get business value. So it probably did end up in more people clicking on the ad, but it probably didn't end up in more shoe sales. But it probably did end up in more pissed off users. Okay, so still on the topic of metrics, beware of measuring just one metric. So although it's good to call out one metric in your hypothesis, one key metric, it's also really important to keep an eye on what's going on below the surface. So you should measure things like latency, like error rates, and these kind of metrics, they don't necessarily need to tie back directly to business value, but it's really important to measure them just to make sure they're not degrading in pursuit of that one key metric that you're trying to improve. But at the same time, slightly contradictory, beware of measuring too many metrics. And this is because every comparison you make, so every different metric you test, or every different variation or different segment of users that you look into, these are all comparisons and they all bring their own chance of a false positive. So naturally, the more things you measure, the more comparisons you make, the higher the probability is that you will run into a false positive somewhere. And it really adds up a lot. So this graph here is showing what your chance of seeing at least one false positive would be, depending on how many metrics you're measuring. And this is assuming that you're just using a standard 95% confidence level. So if you measure one thing, you have 5% chance of that one thing giving you a false positive at the end of the experiment. But on the other hand, if you measure 15 things, you have over 50% chance of getting a false positive. So what this means is that if every time you run an experiment, you measure 15 different metrics and you don't account for this, then half the time you're going to be running into false positives. And this makes it really hard to kind of understand what you should do next. So if you see a significant metric, well, you don't know whether that's just one of those false positives or if it's actually telling you something that you can learn from. So luckily, there are safe ways that you can measure many things. One of them is to use a stricter confidence level. And you can do that kind of manually, or you can do it programmatically. So you can do something called multiple comparison correction, which kind of changes that confidence level in an optimal way, depending on how many things you're measuring. So it gives you a way to measure as many things as you want, but know that you can still be confident in your desired level of false positives. The other thing, if you don't want to go down that route, is just to make sure that you retest any of those significant metrics that weren't your primary metric. So if you think back to the jelly bean example, the responsible experimenter there would rerun that experiment but now with green jelly beans as that primary metric. Okay, so another thing to keep in mind when you're experimenting is to make sure that you've collected enough data before you draw your conclusions. And this works in two ways. So the first way is to do with seasonality and business cycles. So pretty much any business is going to have some level of seasonality. And this image here is showing an example of yearly seasonality. So it's showing the number of web searches for a ski jacket versus swimsuit. So obviously, as you'd expect, people are more likely to search for ski jacket in the winter and for swimsuit in the summer. So it's a huge yearly seasonality. But it's not really feasible to be able to capture yearly seasonality in one single experiment. But you should capture as much as you can of the seasonality. So often you'll have kind of weekly seasonality or daily seasonality. So you can think that people that are going to come to your website at 3 a.m. are going to be very different to the people that come at midday, say. So just make sure that before you draw any conclusions, you're using full sets of business cycles so that your sample is representative. So you can imagine a situation where you're testing something which is, say, loved by business users, but hated by leisure users. So it's common for business users to be more likely to come on weekdays and leisure users to be more likely to come on the weekend. So let's say you're running this test and you run it from Monday to Friday and you see a really great, amazing, positive outcome. Well, you shouldn't then stop that test and then go and put it live, because you then wouldn't have the chance to know that those leisure users on the weekend actually hate what you've done. So it could be overall a negative impact. So it's really important to make sure your sample is representative before you draw conclusions. Okay, but then the other part of making sure you've collected enough data is to do with the sensitivity. So each metric will always have a certain level of sensitivity. The more data you have, the more sensitive it will be. Sensitivity is just kind of saying what range of impacts would your experiment be likely to be able to detect. So it's often characterized by the minimum likely detectable effect. So this is just saying what's the smallest real impact that you would expect to result in a statistically significant metric most of the time. So it's really vital to understand this and to consider it in the experimental design phase, because you won't be able to say anything about any sizes of impacts that are smaller than that minimum likely detectable effect. So this is why when you get an inconclusive metric or a not statistically significant metric, it does not mean that you had no impact, right? It doesn't mean you didn't impact your users. It just means that you weren't able to detect anything. So you can imagine that you don't see a significant change to your key metric, something like purchases per user. Well, if your minimum likely detectable effect for that metric happened to be 10%, then you could have increased purchases by 9%. And if you don't go ahead and make that change, then you're losing out on an opportunity to increase purchases by 9%. You could also have decreased purchases by 9%. So the point is that you just don't know. So you need to understand what that minimum likely detectable effect is, so you can know what you can interpret from those insignificant metrics. And so this logic also applies to guardrail metrics, right? So maybe your test is looking really great for a key metric, but the sensitivity of one of your guardrail metrics is really poor. Well, then if you do that, you can't really be confident that you haven't unknowingly had this negative impact that's going to come back and bite you later. So it's super important to make sure that you understand the sensitivity of your metrics and that you're happy with them before you draw your conclusions. So pay attention to sensitivity, both in the design stage, when you're deciding how long to run an experiment, but also in the analysis stage when you're drawing your conclusions. Okay, so then last responsibility, I think is the most fun one, is of course to take actions based on the results. So make sure that you interpret your data and you're making the best data-driven decisions and making the best next steps that you can. So at a high level, there are 3 main kinds of outcomes for your metric. So if we assume here that there are no issues seen in your guardrail metrics and everything else is looking good, then you probably want to decide your next steps based on that key metric that you pulled out in your hypothesis, because you're a responsible experimenter. So firstly, if you're lucky enough to get the coveted significant metric that's moved in the desired direction, then go and celebrate, right? So it looks like your hypothesis was right and you found a great improvement. So you want to continue to ramp up that experience, let all the users see it, and maximize the value. You might also want to see if there are other segments of users or other areas of your product where you can try and reuse that idea and get even more success. But on the other hand, if you get a significant metric that's moved in the undesired direction, well, no celebrations there. If you're running a standard fixed horizon test, then unless it's a really costly drop, just don't be tempted to stop early just because you're seeing a negative impact. So make sure you run for that intended time unless you really want to lose all the information you could gain from that test because it's too costly. But if it's still significantly negative at the end, then of course kill that experiment so that no one else can see that negative, that unintended change. And then you might want to go and look into the data, see if something's going wrong, see if people are responding in unexpected ways. So maybe you can find some kind of red flags or some insights that will give you an idea of how to reiterate on implementation and then retest that idea. Or maybe you want to bin it completely. But then if you get this kind of this other outcome, which is that you see an inconclusive metric, so if you don't reach significance at all, and the first thing is just to remember that that doesn't mean you didn't have an impact. So you can't be confident that there was one because you didn't see significance. So it could just be due to noise and randomness in the data. So the first step here is to understand that sensitivity and understand the minimum likely detectable effect, because then you know what range of impacts you can rule out. And if that isn't enough for you, maybe you want to consider rerunning with a larger sample size to see if you can find any of those smaller impacts. But if you're often seeing these kind of results, then maybe you want to consider testing bigger and bolder changes, things that are going to have larger expected impacts and things that are going to give you more chance of seeing a significant result. Okay, so that was 4 reasons why experimentation is super powerful and totally worth investing time in. And then 4 things to keep in mind to make sure you're getting the most value you can out of every experiment you run. So I'm just going to wrap up by leaving you with a few key takeaways. So firstly, experimentation lets you start to focus on real value. So instead of looking at output, how many things you're changing, how many features you're delivering, you can start focusing on outcomes. So how are you really impacting the end users and the business? Experimentation gives you a way to gain confidence and safety in your deployment cycles. So if you really get in the habit of releasing all of your features behind an experiment, then you can get that amazing kind of precision and accuracy that lets you quickly detect issues and pinpoint what's causing them. So you get a lot of that safety every time you make a change. And then finally, with great power comes great responsibility. So make sure you're following these best practices to make sure that you're getting the most accurate and the most insightful results you can. Cool, and that's all I've got. Happy to take any questions.
Awesome, that was amazing. I can't believe you got through it so quickly. I went through the deck when you sent it. I was like, this is going to be awesome. I have 1 question so far on the TLC calls channel. So just to remind everybody, you can go to the TLC Slack and add your questions. But you can also use the chat or you can take yourself off mute. But let's start with Tim Wilson's question, who we also need to criticize because he posted the question and then immediately left the call because he's too busy and important, but we all still love him. Tim asks, what about cases where controlled experimentation is not possible, absolutely or practically? What do you think about quasi experiments and or applying causal inference techniques to observational data? And should that fall in the domain of TLC types to learn and apply those techniques and understand their limitations?
Yeah, I think quasi experimentation is awesome. I think it's a super interesting area from kind of data science statistics viewpoint, but it is also really valuable. So I think people often get a bit kind of scared of experimentation sometimes, and they think that they can't do it. Maybe they don't have enough users, enough of a sample, or they don't have the ability to do randomization. But there is always ways to use kind of scientific techniques to get those accurate results and make good decisions. So I think it's super important. It's not something I've had the opportunity to do too much, but I'd like to do some more.
But it is something that you agree that experimenters in general should learn more about, and when possible, take advantage to utilize when they can't.
For sure, yeah.
Controlled experiments.
Yeah. Cool. Any kind of data that helps you make better decisions, you should always do it if you can.
Awesome. All right, opening the floor. Who else has questions for Miss Lizzie? Paula is typing, so 1 moment, please. While she's doing that, I posted a question on the TLC calls channel about hypotheses, because I found it very interesting, the formula that you laid out. I've seen so many different formulas for hypotheses. What do you think are the most important components of hypotheses to ensure that they are both, of course, testable and refutable? What components of the hypothesis do you care most about?
I think the key metric that you're going to make the decision on. So I think people often kind of blow over that stage a little bit, and they'll say they want to increase bookings, but you really need to be kind of specific about it and say, I want to increase the average number of bookings per user, ideally over a set period of time. So I think, yeah, think very kind of precisely about how you're going to measure that metric, so that you
want to increase the amount you want to increase it and who you want to increase it with.
Yeah.
Awesome. Enrique, you want to ask your question?
Yeah, I think this is awesome. It was a great presentation. But I wanted to ask about integrating this in the agile process, where you could have a user story that would be the experimentation case, and then iterate with variations over time. Have you done that with your tool or integrated like that?
So you mean, can you maybe clarify that a little bit more? Sorry.
So, I mean, in the agile process, you have user stories that have cases, and I'm thinking that I don't know, I've always imagined this would be such a great thing to do, is to have a user story that was an experiment idea, and then it goes into production, and then you have the outcome and you measure it as the test, and then the next iteration is a variation of the test with the new criteria to enhance. I mean, maybe this is a fantasy of mine, but I don't know. It seems like that would be a great way to do that. And, you know, because I was in a session last night about agile and analytics, and it's like, this is I think that to get it in a full production scale, as opposed to a side thing that just data scientists do, to get it actually in the development process.
Yeah, for sure. That sounds like definitely a great situation to be in. I think one of the difficulties is getting that experimentation culture in the organization. So it's always going to be a lot of work that needs to go into making it just kind of part of the way people think about doing their product development and their processes. And that, I think, takes a lot of time. It's not easy, but adding it into processes officially is a great step to do that. So to make it part of your agile processes, I think would be a really valuable thing to do.
He
Thanks.
also had to drop, but I wanted to call out Enrique, and this is a good thing to think about. Dylan Lewis and I were having a chat on the Slack last night, and he was trying to assess culture, as you mentioned, Lizzie, and he started going through various different companies, roles and career hiring, whatever pages. And looking for the word, just searching for the word experimentation. Gives you a really, really quick feel on which companies actually have ingrained experimentation into the culture, if they don't even have any roles that, you know, utilize the word. It's pretty telling.
Absolutely. Probably rarer than I would like it to be, but I think it's going in the right direction.
I think it is too. I think it is too. Paula asked if you have an example of quasi experiments, and I don't know if that's a question for you, if you're willing to answer, if you can answer, or we can ask Tim when he's available too, since he brought it up.
I think sometimes when it's something to do with pricing, it's hard to do a proper control trial, right? Because you can't change prices for some half the population and not for the other. So that's one of those times where you might need to think about a different technique. And then you could do it where you're either kind of changing pricing for everyone at certain times and watching how it kind of goes up and down as you make those changes, or by separating people into kind of maybe geographical groups or some kind of cluster of people. And then you, rather than do it randomly, you're kind of controlling and randomizing those groups of people.
Better explanation than I've ever heard. That works for me. I got more questions coming. Anyone else? Lizzie, as you have worked with clients, so you went from, you know, booking, and I'm sorry, I keep forgetting the name, the
Skyscanner.
Skyscanner. I was gonna say SoundCloud, so close, but totally different. Skyscanner and now at Split. So you've gone from like doing it and being the data scientist to a platform. How did your experiences doing the experimentation and supporting the experimentation in companies like Skyscanner and Booking influence the work that you've done on the back end with the platform?
Hugely. So I think one of the difficult parts of now working for a platform is that the best thing isn't always what people ask for, right? We get a lot of requests to kind of do things that are going to get people the significant results they want to see. But having been on the other side of the table, I've had kind of experience firsthand people's those biases that come in, right? When people want to find that positive result, they want to put a feature live because they've worked on it. So I've experienced how maybe giving them more information than they actually need can sway them to make a bad decision. So it's been really valuable to watch people interpret data and see how they use that to make their decisions. And then that helps me kind of try and think about what kind of data we should show and what kind of data we shouldn't show.
And how you display that data. It's one of my favorite parts about Split is the documentation where you had a big part in. Yes. I know, it's very nice. I use it a lot to help explain concepts to some of our clients. So one of the things that I find very interesting is the way that you describe the sensitivity and, you know, all the sample size estimations and stuff like that, and the different available tools that you've provided for clients to do that. So can you talk a little bit about minimal detectable effects and how that changes and how you do those calculations differently and the importance of doing them to avoid a bunch of inconclusive results?
Sure. Yeah, I think this is probably one of the things that I find experimenters are most likely to skip, but is super important. So people don't really realize how much it impacts like what you're going to see at the end of it. So people will often kind of think that they should just run a test for 2 weeks because that's what everyone else does. But it's really worth investing the time to understand if you do run it for 2 weeks, what kind of impacts can you actually detect, right? So if you don't do that step and you don't understand the sensitivity and you just run it for 2 weeks, maybe you get to the end and you realize that all you know is that there wasn't an impact bigger than 20%. And that's not that valuable. And then you're going to have to go back to the drawing board and you've wasted that 2 weeks and you want to do it all again. So I think it's a hard thing because you've got to first kind of have an estimate of what kind of change you're expecting, which is super hard to come up with. And you've also got to have that existing data of things like what kind of sample size do you expect for the segment that you're targeting? What's the typical metric value? What's the variance in the metric value? So it is a really difficult step, but it's so essential in the design stage.
Absolutely. Paula Sappington asks, do you ever use qual to inform experiments? The qualitative data from any...
To inform like the experiment hypotheses, yes, but not so much in informing the decisions. So I think it's really valuable in kind of maybe prioritizing the kind of things that you test, how you design your features, maybe who you're releasing them to. But when I'm making the decisions, no. So that's kind of the point, is that you just use the data, right? So you've designed some scientific tests, you've already made your decision criteria. So then at that stage, once you're looking at the data, then it's just about the quantitative side. But yes, very valuable in deciding what to test and coming up with ideas.
So have you been able to, I'm trying to remember the talk, have you been able to use your quantitative data to explain why something works?
Interesting question.
Which is where the qualitative can come in, right? A lot of times when we see test results that are counter to our expectations, it's difficult to figure out why. So, you know, frequently we might go qual for ideation and prioritization, quant for the actual experiment. And then we might have to go back to qual to understand why something happened. So I would love to be able to store some of that in a platform.
Yes. Working on that.
Anyone else? Other questions? Awesome. Ian, do you have a question, or is it just, did you come off mute to ask a question?
Yeah, sorry about that. I did. My headphones have a mute button as well that I just happened to hit. In terms of back to that qualitative side, my team loves to see does love to see the qualitative side of the information. And in terms of applying a sentiment analysis, which is quantitative in nature, how would you go about integrating that into a quantitative analysis like this? So it's kind of, I'd say it's the best of both worlds, but it's also a double-edged sword. At the same time, is probably the better way to put it. So would love to get your perspective.
Well, I'm not sure if I'm able to answer that one. Do you mean in kind of a post hoc side? So after you've run the test, you're trying to understand the why, or do you mean in terms of the decision making?
In terms of the decision making.
Interesting. I'm not sure. So what extra value does it provide other than knowing how overall it impacted? So if you're making a decision at the end of the day, do you need to know the sentiments?
Yeah, we're at the very infancy stages of our digital presence, and understanding what our customers like or how much they like it is a big way that we measure impact right now. Not just utilization of the feature on our website, but actual enjoyment of it, right? And I'm sorry, I'm trying to figure out a better way to phrase it, but that's probably the best I have right now.
Yeah, I think it's not something I have a lot of experience in, but I guess if you can make that come out as metrics at the end of the day, you can still use experimentation techniques. So if you have some way of saying sentiment is good, sentiment is bad, or some value for the sentiment score, then you can still use experimentation techniques to make a decision.
So like a net reputation score.
Yeah.
Okay, great.
I can add 2 cents, because this is near and dear to my heart. This is a very super difficult problem. So Lizzie is spot on. If you can turn this into a metric, then you could run an experiment where you try to increase the sentiment metric. The challenge is that a lot of times the ways that we elicit sentiment from customers is by asking them, and that there is a strong selection bias for some people to respond and others not to respond.
Right.
And so these metrics are often susceptible to an effect where what you are doing with the product, so the treatment, doesn't just impact how people feel about it, but it also impacts whether they tell you or not. So my favorite example is if you ask, for example, for NPS scores, there's one way of getting sentiment feedback from people. You could turn that into a metric, and I can guarantee you that if you change your product in such a way that right above where you ask the NPS question, right above that you put the customer service phone number, then your NPS score will go up in that experiment. And it's not because people are more satisfied, right? It's not because suddenly showing them the phone number has made them more happy, but it's because the people who are really upset, they then
just pick up the phone,
call customer service rather than answer the NPS question. So all of the negative numbers are going to be disappearing from that particular score, and so the metric will go up, but you actually haven't solved the underlying problem for customers. And this is often tricky with these metrics that are voluntarily given to us by customers. And so you mentioned sentiment analysis. That requires people typing words, and anything that changes people's inclination to type words will change your measurement, but not for the reasons that you think it did.
Understood. Yeah, we're looking to implement an intelligent chatbot sometime soon, and I'm trying to think through the ways to measure success for the chat service, and it's a very, very difficult challenge at this point. But yeah, I appreciate that insight there.
I won't guarantee that the inflow of typing is constant, then the metrics that Lizzie was talking about would work. But as soon as the experiment itself is changing whether people type or not, then you're in trouble.
Understood. Thank you.
Lorenzo has a question for you, Lizzie. First, great presentation. Let's say your primary metric for a specific experiment is conversion rate, but you also have a secondary metric that you want to keep an eye on, such as repurchase rate after 30 days. Would you recommend waiting 30 days to make a call on your decision, what to do about the test, or would you find a correlating metric to repurchase rate so you don't have to wait 30 days to make your decision and take action?
If you're asking me as a data scientist, then wait. I think, yeah, depends how good that correlation is, right? How much you trust it. And I think the difficulty is when you're doing this experiment, maybe that's a great model for the correlation before, but then maybe you change something which then makes it less accurate. So it's risky. I think that kind of thing is really hard. At the end of the day, you kind of got to sometimes take a leap of faith, and then maybe you want to check in on it, make sure it's working as you expected after the fact. But if it's so important, then I'd say wait those 30 days if you can.
Yeah, I've seen a really interesting example of that where the secondary metric was return rate. And so they did a promotion that had a huge increase in conversion and revenue and all this jazz. And everybody was so excited, and they didn't want to wait the 30 days because the 30-day window for the free returns. And they rolled it out, and it was a big mistake because the return rate shot through the roof, and it was actually a huge negative on the bottom line. So I think it also may depend on what that secondary metric is.
Yeah.
Great. We have 5 more minutes. Does anybody have a final question for Lizzie? It's good. Looks good.
Maybe if people are interested in that particular problem, I can point them to the literature.
Yes,
so
you
this
can.
is an area of research. It's called surrogacy. So you're using one metric as a surrogate for something more long-term. I don't think anyone's cracked it yet.
Yeah.
It's such a difficult problem. And so in the academic world, they're more interested in things like, if we intervene and give people who are unemployed, we give them additional training. One metric you could use is, do they find a job? That's a short-term metric. That's like the conversion. The other you really are interested in is, in 10 years' time, will they still have a job?
Sure.
And so they have exactly the same problems in these types of experiments. So they're looking into surrogates, where you use a short-term metric to make a prediction about a long-term metric.
Right. Or in economics, it's the lead and the lag indicators, right?
Yeah, and in these types of intervention, they're really long experiments. Like, if you're trying to make people's lives better by making sure they have a job in 10 years' time, then think about how long that experiment needs to run.
Yeah, one of the most interesting experimentation programs that I ever got to do anything with was Mayo Clinic, and their overall goal was health outcomes. That's not a quick thing. And how do you tie the web behaviors to long-term health outcomes? Well, you got to make that whole goal tree step back and back and back. Okay, we know that people are more likely to have better health outcomes if they have their preventative care. Okay, so now online, we want to see, did we increase the number of people who signed up for their annual or check-ins or whatever? So it's a really interesting problem, but it is important to think through the latter cohort analysis to find out if that longer-term lag indicator or your actual primary metric changes.
But it's really not different from sort of a funnel analysis, right? Where we're doing essentially the same thing, right?
It's a really long one.
E-commerce one. My wife does cancer research, and they do something very similar where they look at progression-free survival. So rather than looking at, does this person still live 10 years from now, they're looking at, does their cancer not get worse? And clearly that's a sub-ideal surrogate, right? That's not really what we're interested in. We want these people to live a long and happy life, not get more cancer soon. But we need something shorter term that is indicative of the direction that shows us that health funnel. So it's exactly the same problem.
Awesome. Well, Lizzie, thank you very much. The presentation today was fantastic. I loved how you made it approachable and understandable for everyone. Really can't wait to have the conversation in 3 weeks about statistical intuition. I look forward to your contributions then. Thank you, everyone, and we'll talk to you in 3 weeks.
Thank you. Bye.